Good morning, guys. Today we're going to be looking at factoring polynomials. This will be day one, and what we're going to be looking at is being able to factor the GCF, also looking at factoring special factors, and factoring in general. If I have a polynomial with three terms, I have 1, 2, 3. So to start off, right, going back, I believe in Algebra 1, you should have talked about greatest common factors. Factors in general are the numbers that are multiplied together. So here we put multiplied together to get an original number. Right, so if we think of an example, you could think of the factors of 6, let's say. So the factors of 6, you can have 1, 2, 3, and 6. Because you can say 1 times 6 gives you 6, and 2 times 3 is also 6. So these are the factors. These are numbers that are multiplied to give you an original number that they're asking about. Factors that are shared by 2 or more whole numbers are called common factors. Common factors. And then the greatest of these common factors is called the greatest common factor. Okay, so an example for greatest common factors, like if I asked, what's the GCF of of let me think of something, 7 and 14. What's the greatest common multiple that they have? They're both divisible by 7, right? So their GCF is equal to 7. They're both of these terms are divisible by 7. Okay. The distributive property. To understand how to factor out common factors, we must understand the distributive property. Okay, so let's say I have some terms here. Let's say I have A, B, and C. So the distributive property tells me to multiply the first two and then multiply the first with the second. So you're going to end up with multiplying A times B and multiplying A times C. Okay, so the distributive property, we've seen it before. You're just multiplying the number in front of the parentheses. You're making sure that it's being multiplied with each item inside the parentheses. Okay. Let's see. The next thing we're going to look at is looking at distributive property with actual values and numbers, right? So what we want to do is we want to make sure that the term in the front of the parentheses is being multiplied with each term inside the parentheses. So we're going to multiply 3x times 4x. Right, and I usually put parentheses to kind of remind me that these two are multiplying. Then we bring over the plus, and we're going to do 3x times 3. And again, I'm writing the parentheses. So that's going to give me 12x squared plus 9x. Okay. And then, so we have the distributive property up here. We used it and we got the following result. And if we go backwards, if we do the process in reverse, then what we're doing is called factoring. In this case, factoring out what they have in common. So if I look at 12 and 9, you know, what's the GCF of 12 and 9? So the GCF of 12 and 9, they're both divisible by 3. Do they both have x's? Yeah, I have 2 x's here and 1 x here. So they have a GCF of 3x. Okay. Actually, let me write it. Let me write it up here. Let me write it over here. GCF is 3x. Now what we're going to do with this GCF is divide it. Divide it out. And put it in front of the parentheses. Set up a parentheses here. So again, right, this is my GCF. And what do we get if we divide? So what's 12 divided by 3? It's 4. What's x squared divided by x? It's x. Bring over the plus. Then what's 9x? What's 9 divided by 3? That's 3. And x divided by x cancels. So this GCF that I mentioned here, you know, I'm just writing it out to remind us that where we got the 3x from. It came from the greatest common factor. We said both of these terms can be divided by 3, and they both share a common x. So we went ahead and took out the GCF, put it in the front, and divided both terms by that GCF. And we're going to be practicing this again, but just in a small scale. Just wanted to give you an example of the distributive property, and then if I do the distributive property in the opposite direction, it's factoring. Right. The example that we're going to have here, it says factor the following algebraic expressions, show all your work. So again, we were just talking about GCF, so this is what we're going to look for in this problem, right? First, figure out what is the GCF, what is the greatest common multiple. So first of all, I noticed that we have two terms here, but do they both have an x? No, so they don't share that common factor. 24 and 3, are they both divisible by a common factor? Yeah, it looks like they're both divisible by 3. So we're going to take this GCF and divide it out. And we're going to set up a parentheses. Put the GCF in front of the parentheses and then divide. What's 24 divided by 3? It's 8. Bring down the x squared minus, what's 3 divided by 3? It's 1. So this is my answer. Okay, so again, once we figure out GCF, once we figure out what both of these terms can be divided by or what they have in common. Then I'm going to divide the terms by that GCF to give me the inside of the parentheses, and then I'm going to put the GCF in front of the parentheses. Okay. And again, we're gonna practice it again. So for example, let's practice it again in example 2. So first of all, do we have a GCF? They don't share a common x. Are they both divisible by something in common? So I see that there's a 7 here, so I would want to ask, is 56 divisible by 7? 7 times 7 is 49. 7 times 8 is 56. So yeah, so we have 7 is the GCF. But also another aspect about it, whenever you have a negative as your first term, you want to make sure and include the negative in your GCF. So I'm going to put negative 7. Okay, so what are we going to do with this GCF? We're going to divide both terms by that GCF. Then we're going to set up a parentheses for the result we're going to get when we divide. And what do we put in front of the parentheses? The GCF. So let's divide. Negative divided by negative is positive. 7 divided by 7 is 1. So that leaves me with x. Positive 56 divided by negative 7 is a negative. And 56 divided by 7 is 8. Okay. And the thing about factoring, if you distribute, if you multiply it out, if you get an answer and you multiply it back out, you should get what you started with. So you should get the original expression back. So you can always check yourself. You can multiply it out and see if you get the original expression back. Okay, let's go to example 3. Okay, example 3, is there a GCF? Huh. Do they all have an x? No, the first two terms have x's, but the 8 doesn't have an x. Do they have a common multiple, or can I divide 8? See, I can divide 8 by 2, by 4, by 8. But can I divide 3 by 4? Can I divide 3 by 2? Or 3 by 8? Same thing with 1. So at the very least, we would say there is no GCF. At the very least, we could say the GCF is 1. You know, I can divide 8 by 1, I can divide 3 by 1, and I can divide 1 by 1. But remember what I said over here in example 2. If the first term is negative, then we want to include that negative in the GCF. So we're going to include, since the first term is negative, we're going to put a negative as our GCF. And so what are we going to do with this GCF? We're going to divide all the terms by -1. Write the GCF and set up your parentheses. So write the GCF in the front of the parentheses and divide. So negative divided by negative is positive x squared. Negative divided by negative is a positive 3x. And positive divided by negative is a -8. Another way you can write it is you can also write it as negative x squared plus 3x minus 8. So this is two ways to write it. You can write it with the negative 1 in front or with just a negative in front. But at least we know that the GCF is this negative 1. Let's go to example 4. So let me slide over here. Looks good. Okay. The steps for these examples say factoring out the greatest common factor does not just involve numbers, but can also involve variables. Okay, so sometimes the terms have variables in common. And so if that happens, then the variable will be the GCF. So the GCF, for example 4, they don't have any numbers in common, but they do have x's in common. They both have at least one x. You always want to go with the minimum. Even though the first one has 2 and the last one has 1x, you always want to use the minimum amount. So they both have at least 1x. So x is my GCF. So I'm going to divide both terms by x. So I'm going to set up my parentheses, put my GCF in front of the parentheses, put the GCF in front, and then divide. So x squared divided by x is x minus x divided by x, something divided by itself, is 1. Next one, looking for the GCF. Looking at the numbers, is there a common factor between 3, 5, and 6? I can divide 3 by 3, but I can't divide 5 by 3. I can divide 5 by 5, but I can't divide 3 by 5. I can divide 6 by 3, but I can't divide 5 by 3. So as far as the numbers go, they don't have anything in common, but they both have x's in common. The first one has 3 x's, the second one has 2, and the last one has 1. So at the very least, the very minimum number of x's that they have in common is they have at least 1 x in common. So this being my GCF, I'm going to divide all 3 terms by x. So I'm going to set up my parentheses and put the GCF in the front. And then divide. 3x to the third divided by x. It's going to leave me with 3x squared. Right? If I have 3 x's and then I cancel 1, that leaves me with 2 x's. Then I'm going to have positive 5 x squared divided by x is going to leave me with an x minus 6. X divided by x cancels and leaves me with 1. Okay. So I hope we got kind of an idea for the GCFs and finding the GCFs. The next topic that we're going to look at is factors and products. As I mentioned earlier, factoring is the reverse process of multiplying given a certain product. So for example, if I'm working with numbers, right, numerically, if I'm looking at the number 12, I can say, well, what are the factors of 12? I could do 1 times 12 will give me 12. 2 times 6 also gives me 12. 3 times 4 also gives me 12. So these numbers that we're using to multiply to give us this product, these numbers are called factors. Now, what we're going to look at in this class is the algebraic aspect of factors. When you're multiplying not just numbers, but you're multiplying expressions with variables and numbers, what do you get when you multiply? So if you multiply x plus 1 times x plus 3 times x plus 3, you should get this product. And so we're going to be looking at how to factor, how to go backwards to give us, if they give us a product in the problem, how do we find the factors of that product? Okay, so talking about products, there's some special situations for products when factoring. There are a few special products that, if we can recognize them, can help us easily factor polynomials. So it'll benefit us in saying that there's kind of a formula to kind of solve for them, or some sort of formation. So the two special products are called difference of two squares, two perfect squares, which is a squared minus b squared. This is in like symbolic form. And then we have the perfect square trinomial. There's two perfect square trinomials that we're going to look at. Okay, so before we do, let's look at what is a perfect square. Right? Before we look at these special situations, let's think about what is a perfect square. So the definition of a perfect square is a number whose square root is a whole number, and or a variable with an even exponent. So as far as numbers go, we should be familiar with these perfect squares. Right? 1 times 1 gives me 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and so on. So these perfect squares are numbers that, again, I can take the square root and it's going to result in a whole number, right? The square root of 64 is 8. The square root of 100 is 10. As far as variables go, we're just looking at the exponents. So if the exponent is even, so I have x to the power of 2, 2 is even. B to the 4th power, that's 4 is even. 6 is even, 8 is even, 10 is even. So any variables that have an even number exponent are considered a perfect square. Okay, this is kind of just a review of perfect squares. And so, as I mentioned earlier, if we're able to recognize special products, then we can recognize them in our problems, and it simplifies the factoring process. Okay, so for example here, a difference of two squares. This is what it looks like in symbolic terms. It's a number squared minus another number squared. And it's usually made up of two terms. So if we're looking at this equation, if we talk a little bit about it, we notice that there's two terms. The first term is a perfect square, and the last term is a perfect square. And then the last characteristic is, if you notice, there's subtraction going on between the two terms. So these are the characteristics of a perfect square. I mean, the difference of two squares. It's usually two terms where those two terms are subtracting, and the first and the last terms are perfect squares. And then a perfect square trinomial, the word trinomial means three terms. Right, so I have 1, 2, 3. One term, two term, three terms. They're usually separated by a plus or a minus. So this first equation has 3 terms, the second one has 3 terms. So perfect square trinomial is made up of 3 terms. Okay, so if I just have 2 terms, it cannot be a perfect square trinomial because it should have 3 terms. Similar characteristic, the first and the last terms are perfect squares. Okay, so this first and the last are perfect squares. And then the middle term is found by multiplying 2 times the square root of the first term and times the square root of the last term. And what else do we notice? For example, the first equation has 2 plus signs. The second equation has a minus and a plus sign. So these are just different characteristics of the special cases. But let's look at some examples so we can kind of get the hang of recognizing them and looking at the characteristics of them. So let's jump down here. Okay. So here, we're not going to solve anything. We're just going to state, just by looking at them, do we have a difference of 2 squares? Or do we have a perfect square trinomial? Okay, so let's look at number 6, example 6. How many terms do we have? It has 1 term, 2 terms. Okay, is there subtraction going on? Yeah, there's subtraction. And is x squared a perfect square? Can I take the square root of x squared? Yeah, it should give me x. Can I take the square root of 49? Yeah, it should give me 7. So here we have a difference of 2 squares. Let me write that. Let me write it again. Difference of 2 squares. All right, the next term, is it a perfect square trinomial? Is it made up of 3 terms? Let's see, I have 1, 2, 3. Yes, it's made up of 3 terms. Can I take the square root of the first term? Can I take the square root of 9? Yes. Can I take the square root of the last term, n squared? Yes. And then how do I check the middle term? To check the middle term, we have to multiply 2 times the answer that we got when we square rooted. So 2 times 3 times n. So we're going to multiply 2 times 3 times n. 2 times 3 times n. That 2 times 3 is 6, and times n is 6n. So that's the question, is this the middle term? Yeah, is 6n the term in the middle, the second term? Yeah, it looks that way. So everything checks off. So in this case, we have a perfect square trinomial. Right. And then example 8. Do we have 3 terms? 1, 2, 3. Can I square root the first term? Square root of a squared is times a. Yes, I can square root the first term. Can I square root the last term? 25. Yeah, I can. And in the middle term, if I multiply 2 times a times 5, the two answers that I got when I square rooted are a and 5. If I multiply 2 times a times 5, does that give me the middle term? Yeah, it does. But there's one thing that we didn't check for in example 7, right? We need to also check that there's either a plus plus or a minus plus. So if you notice in example 8, we have a plus minus. So that's a problem, because if we go back up here, we should have either a plus plus, which is like example 7, or we should have a minus plus. So we can't have a plus minus. We can't have a plus in the middle and a minus at the end. Do we have that in example 8? Yeah, I have a plus in the middle and a minus in the end. So I'm going to put not a special factor. Okay, let's jump over to example 9. Do I have subtraction of two terms? I have one term in the front, second term over here. So it's two terms, they're subtracting. Can I square root 1? Yes. Can I square root 36y to the 4th? Yeah, what's the square root of 36? That's 6. The square root of y to the 4th is y squared. So this checks off. So we do have a difference of two squares. Okay. Let's look at the next part here. Factoring special products. These are kind of some steps to factor, to help us factor. And so, for example, if I have a difference of two squares, I need to square root the first term, square root the last term, and then write a plus b and a minus b. But I need to make sure that there's two terms. I need to make sure that there's subtraction, and I need to make sure that there's square rooting. Now, when you square root the first term, that's going to equal to, actually let me write it in blue, that's going to equal to a. When you square root the last term, that's going to equal to b. Same thing over here, if I square root the first term, it's going to give me a. The second term is going to give me b. But once I figure out what my a and my b are, then I can write a plus b, a minus b for the difference of two squares. And then for a perfect square trinomial, we either write a plus b times a plus b if the equation has two pluses. But if the equation has a minus and a plus, then we're going to write a minus b times a minus b. All right, so again, once we start practicing the problems, then they make a little bit more sense. So let's look at some examples here. So factoring polynomials, factor the polynomials. So we have to figure out, is this a special case? Are there 3 terms? I have 1, 2, 3. 3 terms? Yes. Then I want to check, can I square root the first term? Can I square root the first term? Yes, gives me x. Can I square root the last term? What's the square root of 49? That's 7. Okay, so these check off. So that means that this is my A, and this is my B. Okay, I'm going to zoom out over here. So what I mean by A and B is right here. So I square rooted the first term. The square root of x squared is x. I square rooted the last term. The square root of 49 is 7. So this is my A and my B. And so I'm going to end up getting either A plus B, or A minus B. But it depends on the equation. Do I have a plus plus situation or a minus plus? So I have a minus plus. Sorry, I have a plus plus. So it's going to be A plus B. But yes, that's going to be it for that one. But I also want to check, what do I get if I multiply? Zoom in over here. What do I get if I multiply 2 times A times B? Is that the middle term? Right, so I'm looking at the middle term. And I'm going to substitute, so 2 times A, what's A? A is x, times B, what's B? B is 7. So what's 2x times 7? That's 14x. Does that match the middle term? Yes. So we have a perfect square trinomial. So since I have a plus plus, we're going to write A plus B times A plus B. But what is A? A is x plus B is 7. And then I'm going to write it again, x plus 7. And this is my answer. So if I multiply these out, if I do the distributive property, I should end up getting back the original equation here. Okay, so let's look at example 11. I have m squared. So I have 2 terms, 1, 2. There is subtraction. Oh. The writing tool's not working. Okay, there's subtraction. Yes, check mark. Then the next thing is, can I square root the first term, square root of m squared, is m. Can I square root the last term? Square root of 64 is 8. So this is my a and my b. So I could square root both. There's subtraction going on. So we have a difference of squares. A difference of squares. So if we go back up here, if I have a difference of two squares, then my equation is going to be a plus b times a minus b. A plus b times a minus b. So going back to example 11, I need to write a plus b times a minus b. So my answer, I'm going to set up my two parentheses. My a is m, b is 8. So it's going to be m plus 8, m minus 8. That's my answer for that one. But notice, where am I getting the a and the b from? It's from square rooting the first term and square rooting the second term. Square rooting the first term, square rooting the second term. That's where I'm getting my a and my b. How do I know to put a plus b or a plus b and a minus b? It depends on what special product I'm working with, right? If it's a difference of two squares, then my formula is a plus b, a minus b. If I'm working with a perfect square trinomial, then it's either going to be a plus b, like a copy of the same thing if both signs are plus. If I have a minus plus, this situation, then they're both going to be minus. So let's look at example 12. I have two terms, 1, 2. There is subtraction going on. Can I square root 9y squared? Yes, the square root of 9 is 3. The square root of y squared is y. Can I square root 25? Yeah, that's 5. So I have my a and my b. So I'm putting check marks to say that I can square root them, right? I can square root 9 and y squared. I can square root 25. That gives me my a and my b. And so for a difference of squares, my formula is a plus b times a minus b. So set up my two parentheses. My a is 3y. So it's 3y, and I have a plus and a minus. And then my b is 5. So it's going to be plus 5 minus 5. Okay. Let's go over to number 13. Right. Do I have two terms? Yes. Yeah, are those two terms subtracting? Yes. Can I square root? Can I square root 1? Yes. Can I square root 36n squared. Square root of 36 is 6. The square root of n squared is n. So yes. So I have my a and my b. So I have a difference of squares. So my formula is going to be a plus b, a minus b. Setting up my parentheses. My a is 1. My b is 6n. 6n. One's going to be plus. The other one minus. Okay. Example 14. I have 1, 2, 3 terms. Then I want to check, can I square root the first term? Can I square root 9? Yes, the square root of 9 is 3. Can I square root the last term? 16r squared. Yeah, the square root of 16 is 4. The square root of r squared is r. So I have my a and my b. And then I want to check the middle term. Well, actually not the minus part, but just the number. So just 24r. And so I want to multiply 2 times a times b. 2 times a times b. 2 times a times b. So 2 times 3 is 6. 6 times 4 is 24r. Does that match the middle term? Yes. So everything checks off. The other question is, do I have a plus plus or minus plus? If I have a minus plus, then that means that when I set up my a and b parentheses, they're both going to be minuses. So my a is 3, my b is 4r, and they're both going to be minus, or subtracting. All right. Next, we're going to look at factoring trinomials. Not all polynomials are the result of special products. So sometimes there's nothing special about the polynomial that we're working with. So we need to have another method for factoring. So the method for factoring, not there. So usually we have, like this last term here, we call this C. The middle term, we call it B. And what we're looking for is two numbers to multiply to give me C and add to give me B. And so let's practice just by doing an example here. So let me zoom in here. Okay. So we set up a table. But first of all, you want to ask yourself, is this a perfect square? Is this a special case? Because I do have 3 terms, right? Can I square root the first term? Yes. But can I square root the last term? No, I cannot. Right? So if the special case method doesn't work, then we have to think of another method to use. And so what we come up with is making a table where on one side we're looking to multiply to give me the last term, multiply to give me 3, and add to give me the middle term, 4. So can you think of two numbers that multiply to give me 3? Well, there's only one, right? It's 1 times 3 gives me 3. And using the same numbers, right, 1 and 3, what happens if I add them? Does that give me the middle term? Yes. So both check off. So if they both check off, if I find two numbers that multiply to give me the last term, and those same two numbers add to give me the middle term, then we've solved the problem. And so we've set up our two factors, our two multiplications. What's the variable that we're using? We're using x, right? And what were the numbers that worked? It was positive 1 and positive 3. So positive 1 and positive 3. So that's my answer. Now, we can check it, and I'll check it with you just to kind of show you why it worked out that way. But if I multiply, for example, x times x, that's going to give me x squared. And then multiply x times 3, it's going to give me 3x. Then I'm going to multiply 1 times x and 1 times 3. 1 times x is going to give me 1x, plus 1 times 3 is going to give me 3. Combine like terms. I can add the 3x and the 1x. So I'm going to bring down the x squared. 3 plus 1 is 4x. And bring down the plus 3. So when I multiply it back out, does it give me the problem that I started with? Yes, right? X squared plus 4x plus 3. So that's kind of the idea behind the problem. Is we're trying to factor, we're trying to figure out what numbers multiply to give me the term at the end, and then add to give me the term in the middle. So this is my answer here. And so let's jump over to, where am I? Yes, oh, okay, so 16. Wait, yeah, this is 15. Yes, so we're going to jump over to 16. All right. So here we can check it and we can say, oh, it looks like a perfect square trinomial. I have 3 terms. Can I square root the first term? Yes. Can I square root the last term? Yes. So this is my A and my B. So now I'm going to check the middle term and check, what's 2 times a times b. It's going to be 2 times r times 4, which is 8r. Does 8r match the 10r? No. So they don't match. So it's not a perfect square trinomial. So if it's not a perfect square trinomial, then we have to use the table method. We're going to call it the table method. So I set up my table. We're going to look for two numbers that multiply to give me 16, and those same two numbers that multiplied to give me, when I add them, give me negative 10. Okay, so two numbers that multiply to give me 16. You could say 1 times 16, that gives me 16. But what do I get if I add 1 and 16? That gives me 17. So I don't want 17, I want negative 10. Alright, so then you might say, okay, what about 4 times 4? 4 times 4 is 16. But 4 plus 4 is 8. Okay, but then you might say, okay, negative 4 times negative 4 is also 16. So what's negative 4 plus negative 4? It's negative 8. Okay, so I can't get 10, right? I can't get negative 10. But am I missing a multiplication here? Could I also multiply 2 times 8? Yeah, 2 times 8 is 16. And what's 2 plus 8? That's 10. But I want a negative 10. So can I try negative 2 times negative 8? Yes, that's positive 16. And if I take those two numbers, negative 2 and negative 8, and I add them, that gives me negative 10. So I found my match. There's a lot of trial and error, but I found my match. And so what's my factors are going to be dependent on what's the letter that they're using, right? Are they using X, Y, using R? So R and R. And the combination that worked was negative 2 and negative 8. Negative 2 and negative 8. Fix this. Right, 17. Can I square root 12? No, so then it's not a perfect square. So I would use the table method right off the bat. So I'm looking for two numbers that multiply to give me negative 12, and two numbers that add to give me, what's the number in front? To give me 1. Positive 1. Alright, so we're looking for negative 12, so we can think of, one has to be positive, the other one negative. So we can think of maybe, negative 1 times positive 12 gives me negative 12. So that checks off. But then when I add them, right, negative 1 plus 12, does that give me 1? No, it gives me 11. or actually, let me cross out 11. Okay, so we do kind of trial and error. We could try -2 and 6. Does that give me -12? Yes. But what do I get if I add the two numbers, -2 and +6? That gives me +4. But I want to get a +1. So that doesn't work out. And then what about -3 and +4? If I multiply them, that gives me -12. What do I get if I add them? What's -3 plus 4? That's +1. Huh, I have a winner. So both of these checked off. So my answer is going to be M and M. I'm using M because that's the variable in the problem. And the number combination that worked was -3 and +4. So -3 and +4. Right, and then let's look at the last one, the table method. So I'm looking for two numbers that multiply to give me -15, and when I add them, give me -14. So I can try -15 times 1. That gives me -15. Yeah, that's what I want to get. And then if I take -15 and I add it with 1, that's going to give me -14. So I have a winner here. And so my parentheses, set up my parentheses. What's the letter that they're using? They're using A. So I'm going to put an A here, an A here. And the combination that worked was -15 and +1. -15 and +1. Awesome. So that concludes our notes for today. Again, we're going to be looking at any questions you may have during the class time. But thank you for joining me today. I'll see you guys in class.